Now look student, today we are going to solve that exercise 2a class 8 advanced maths question number 8 Roman 1. This is the question as you can see in the video. Question number 8 contains total 3 sum, Roman 1, Roman 2 and Roman 3 as you can see in the video, and we are going to solve all the sums one by one. First one is 8 Roman 1, we are going to solve now. Students, this is the question of 8 Roman 1, and since the question is given as show that, so this is the LHS, means the left hand side. Now from the left hand side I'm going to start solution. Now look student, after that here 1 by, and look here 1 plus a to the power x minus y. There is also 1 by a to the power 1 plus a to the power y minus x. We are going to express now this one. First of all we'll split up. So 1 plus there is a to the power x into a to the power minus y. Similarly here also 1 plus a to the power y into a to the power minus x. This dot means into. Now after that here 1 by 1 plus a to the power x, and this is a to the power y. After that here 1 by 1 plus a to the power y by a to the power x. Now after that if I go for the LCM here will be easy. Now we are going to LCM. There is a to the power y plus a to the power x by a to the power y, and there is 1, and after that here 1 by a to the power x plus a to the power y by a to the power x. Now look, 1 by this, which means this will go on reciprocal. So after that here this will go on reciprocal, so a to the power y, and there is a to the power y plus a to the power x. Similarly here also 1 by this, which means this will go on reciprocal. So this is a to the power x will be here, so next one a to the power x plus a to the power y. Now look, there is a to the power x, there is a to the power y. So if I go for the changes, since there is a plus sign, so we can change the value, means interchanging with first and second, because there is a plus, and this is will keep remaining same. Next one here a to the power y, and this is a to the power x plus a to the power y, plus there is a a to the power x and a to the power x plus a to the power y. Now if I take the LCM here, what will happen? LCM is a to the power x plus a to the power y. Now answer also here a to the power x plus a to the power y. Now go for the cancellation. Answer is 1, which is RHS. Therefore the last line will write that there since LHS equal to RHS, therefore 1 by 1 plus a to the power x minus y plus 1 by 1 plus a to the power y minus x equal to 1. Hence proved. Proved. P-R-O-V-E-D. Hence proved. This is the first one. Students, now we are going to solve that 8 Roman 2. This is the question, and this is also we have to show that. So this is our LHS and this will RHS. We have to start from the LHS and we'll go to the RHS. Now let's have a look how to solve this one, 8 Roman 2. Now student, we are going to solve that 8 Roman 2, and this is the LHS which I have written here now, as you can see in the video. Now just after that there a minus b root of p to the power a whole to the power 1 by a minus c. Similarly b minus c root of p to the power b whole to the power b minus a into c minus a root of p to the power c 1 by whole to the power 1 by c minus b. Now look student, after that here, so first of all we'll remove the root over. How to remove this? Look here, p to the power a whole to the power 1 by a minus b, and in the second bracket and whole to the power 1 by a minus c. It is like student, wait, I'm just going to show you that. Look here, since it is cube root of 2, so we'll write that 2 to the power 1 by 3, or if it is fourth root of 2 cube whole to the power 1 by 3. This will be like 2 cube whole to the power 1 by 4, then in second bracket 1 by 3. We can write like this. So here it is given, look here now, it is given a minus b root of p to the power a whole to the power 1 by a minus c. That's why just removing the square root, like p to the power a 1 by a minus b whole to the power a minus c. And similar way we'll write here also that p to the power b whole to the power 1 by b minus c. Now in second bracket, then whole to the power b minus a. After that multiply, then p to the power c whole to the power c minus a whole to the power c minus a, then in second bracket 1 by c minus b. Look now student, after that we are going to multiply this p to the power a, p to the power a into this value, which means a by a minus b, and then whole to the power 1 by a minus c here. After multiplying, next would be p to the power this b into 1 by b minus c multiplied b into 1 by b minus c, then whole to the power 1 by b minus a into p to the power c by c minus a, then whole to the power 1 by c minus b. Now look, after that we'll go for the multiplication here. So answer would be, look here now, answer would be that p to the power a by a minus b into 1 by a minus c, okay, then into again p to the power b by b minus c, then 1 by b minus a, then p to the power c by c minus a, then 1 by c minus b, like this. Now student, look after that here that p to the power, now we'll go for the multiplication here, then a by a minus a minus b and a minus c. Now if I go for the multiplication here, so a into a square, or directly we can write one thing, that p to the power a by a minus b, then a minus c into p to the power, that is b by b minus c, then b minus a, into p to the power c by, look here now, c minus a, then c minus b. Look now, since base is same, power should be added. So p to the power a by a minus b, then a minus c, plus b by b minus c, then b minus a, plus c by c minus a, then c minus b. Now after that, now student, look after that for solving this portion I have written this line again here. Now after that, look, just make some changes here, that a by a minus b, and there is a minus c, first one. Now here if I make some changes here, like if there is a minus b, so if you make here a minus b, then there will be sign b by b minus c, and there is b minus a. If I write here a minus b, then there will be minus. Now similarly here also there is a minus c, so if I make some changes here, then c by, look, a minus c, and this is it is c minus b, is not it? So if it is like b minus c will be here, so there will be again plus, so b minus c. Now look after that student, I repeat again, there is a minus c, so first I make a minus c here, then if there is a b minus c, so make here b minus c, so minus minus plus became here. Now look here that b minus c is here, so if I want to make it a minus b, so sign will be here minus. Now look, if I take the LCM, will be easy. Take the LCM now, first here a minus b, which means obviously a minus b one time will be here, a minus b, then b minus c, then c minus a, or we can say that a minus c here, yeah, as it is given here that a minus c, we'll write here a minus c. Since it is given in here a minus c, so we'll write here that a minus c. Now look after the student, just after that a minus b, a minus c, a minus b, a minus c cancel, so answer is a into b minus c only. Now minus b minus c, a minus b cancel, remaining a into a minus c, and next one is a minus c, b minus c, a minus c, b minus c cancel, remaining part is c into a minus b. Now if I go for the multiplication here, what will happen? Look here now, p to the power, now look, since this will remain same, that a minus b, then b minus c, then c minus a, So here will be AB minus AC after multiplying this one. Now minus AB, minus plus BC. Now here again, AC minus BC. Now look here, AB and AB cancel, then AC cancel, then BC cancel. So answer would be here that p to the power 0 by a minus b, then b minus c, then c minus a. And the next part we'll write that p to the power 0 by this value means 0, p to the power 0, and p to the power 0 is equal to 1. This is our RHS. So in the last line we must will write that since LHS equal to RHS, therefore we'll write the question equal to 1. Now look, so here you can write that second bracket, then a minus b, p to the power a whole to the power 1 by a minus c into, next here b minus c, then root over p to the power b into 1 by b minus a into, then c minus a root over p to the power c, second bracket 1 by c minus b equal to 1. Hence proved or showed. Now look student, 8 Roman 3, this is the question given here equal to 1. I repeat again, this is the question given here equal to 1. This is the LHS side, this is RHS, and condition is given m plus n plus l equal to 0. So we have to solve this one. Now we have to show this equal to 1. Let's have a look how to solve this one. Students, this is the question number 8 Roman 3, and this is the LHS part, means left hand side part. Student, this question is very much important. Normally it comes into the examination, and now we are going to solve this question now. Look student, after that here first of all I will write that 1 by a to the power l plus a to the power minus m plus 1, and plus here. Now if I go for the multiplying both the numerator and denominator with a to the power minus m here and here also. Now look, a to the power m plus a to the power minus n plus 1. If I cancel these two, we'll get this one again. And similarly here also 1 by, if there is not 1, is a to the power l. A to the power l, if I multiplying both the numerator and denominator with a to the power l, then this could be like this. Cancel these two, we'll get this one again. Now look, after that now we'll go for the multiplication. Now 1 by, this will remain same, a to the power l plus a to the power minus m plus 1 will remain same, and after that a to the power minus m. Now if I go for the multiplication here, then base same, power should be added. So a to the power m into a to the power m plus there is a to the power minus m into a to the power minus n plus a to the power minus m here after multiplying all this. Now similarly here also this will remain same, that a to the power l. Now a to the power l into a to the power n plus a to the power l into a to the power minus l plus a to the power l. Now look, after that here if base same, power should be added, So similarly here also that I am going to write now. Look here, this will remain same, that 1 by a to the power l plus a to the power minus m plus 1, and plus here a to the power minus m here. Now if base same, power should be added, minus m plus m, and here also a to the power minus, if I minus m minus n, if I take minus common, then minus m plus n here. If I take minus common, then minus m plus n, and next one would be here, that plus a to the power minus m. This is for the second part. Now look, for the third part here also we'll do the same, that a to the power l. Now here a to the power l plus n. Now here a to the power l minus l, means plus l minus l. Now a to the power l only. Now look here, after that student, next step, this will remain same, 1 by a to the power L plus a to the power minus m plus 1. Now after that a to the power minus m, so plus m minus m cancel, a to the power 0, and this a to the power minus m plus n plus a to the power minus m, and this one also, if I write like this, that a to the power L, and here is a to the power L minus L plus a to the power L plus n, and plus and minus n cancel, so a to the power 0 and a to the power L here. Now after this part I will use the condition. The condition is given in the question, that okay, first of all I am taking this one as equation number 1. Now after that I am now going to this whole as equation number 1, this whole as equation number 1. Now I am going to use the condition now here. Now look student, after that the given condition is given m plus n plus L equal to 0, the given condition. Now after that if I write here that a simple L equal to then minus m minus n, or if I write here just after that only m plus, just if I take that next one L plus, if I take only n here, then this could be minus m here, m plus n plus L equal to 0. Now if I keep L here, if I take these two on that side, it become minus m minus n, and here which means minus m minus L, or it's better if I take minus common, then m plus n. Now look here student, in place of m plus n, look, in place of n plus n I can use L, since minus m plus n minus m plus n, so in place of this one I can use L here. And one more thing, if I take only n in this side, it become n plus L plus n now, and minus m will be here. So look here, in place of L plus n I can use minus m there. So now I'm going to just apply this condition into equation number 1. Look student, from 1 I have just written the equation number 1. Now look, after that student, before applying the condition here, I will make some changes here. Now what are the changes? Look here now, 1 by this a to the power L plus a to the power minus m plus 1 will remain same. Now plus a to the power minus m, a to the power 0 means 1, and there a to the power minus m plus n, already I have shown you that this equal to L, and there is a to the power minus m, and next one here a to the power L, so L plus n equal to, already I have shown you, there is a to the power minus m, and a to the power 0 means 1, and then a to the power L. Now look here, I will just look here students, all these denominator are same, but we just need to make some changes here. So we'll go for the changes again. This will remain same, a to the power L plus a to the power m plus 1 plus a to the power minus m, and there is, if I write like this, a to the power L plus a to the power minus m plus 1, and next one would be after that a to the power L, then a to the power L plus a to the power minus m plus 1. Now look, all the denominators are same, so if I take the LCM here, what will happen? LCM will be only this one, a to the power L plus a to the power minus m plus 1, this will be the LCM. So here 1 plus a to the power minus m plus a to the power L, so this will again go for the changes. Now in the last line we'll write that a to the power L plus a to the power minus m plus 1, and denominator is also a to the power L plus a to the power minus m plus 1. Now cancel these two, answer is 1, which is our RHS, right hand side. Now in the last line I will write that here, look here to the last line, since LHS equal to RHS, therefore 1 by a to the power l plus a to the power minus m plus 1 plus 1 by a to the power m plus a to the power minus l plus 1 plus 1 by a to the power n plus a to the power minus l plus 1 equal to 1, hence showed or proved. This is the answer of 8 Roman 3. Again I will tell you student, question number 8 Roman 3 is important and practice this one.